Hey everyone, today what we'll be looking at is simple interest graphs. So we last explored the concept of simple interest, which is I is equal to PRN, and we're about to graph this to see what kind of behavior that this exhibits. So example 6 says Rachel invests $20,000 into an account that earns 6% per annum simple interest. Construct a graph that shows the simple interest I earn in dollars for n years for values ranging from n equals to 0 to 8. So I've just created a table here, but the thing is we need to actually generate a formula for us to actually input these n values. So I is equal to PRN, as what we discussed before. The principal in this case is going to be 20,000, as we can see here. So we're going to write 20,000, and then we'll pop in that rate of 6% per annum. Okay. So that's like 0.06, or you can write 6% if you wanted to, times n, okay, which we don't know, all right? Or we do know, but we're not going to put that in there yet. And then once we get that value, okay, done, we can multiply these two numbers, and that will give us 1,200. So that will allow us to get our formula being I equals to 1,200 times n. So if we multiply 1,200 by each of these numbers here, which are our n values, then we'll get 1,200. Oh, sorry, no, it's not. It's 0, 1,200. 2 times 1,200 is 2,400. 3 times 1,200 is 3,600, and then so forth. Okay. So I'm just going to fill up all these values, like so, okay? So, what I want you to actually look at also is that this number here is actually our gradient, okay? If you imagine y equals mx plus b without the b, because that's 0, and here's our value before the x term, which in this case is n, that number there, 1,200, is our gradient, which means that every single time n goes up by 1, which is the number of years that goes up by 1, we're earning $1,200 in total. Okay, you can see the difference between one number to the other is 1,200. Okay, and we're going to explore that later. Right. So once we get that and we graph this out, okay. So using graph paper, you would have your n value, which is your independent variable, on the x-axis right here, and then your interest, which is this value, these values here, on the y-axis. And you can just go up by 1,000, really, okay? So once you plot that out, you do get a straight line like that, okay? So simple interest graphs do involve straight lines, and we're later going to have a look at compound interest graphs, which are not straight lines. But I'll talk about that later, right? So for now, just recognize that it's straight lines that we're looking at, okay? Now, B, what does the gradient of this graph represent? So our gradient here is basically rise over run, okay? So if I just grab this point here, which is just this value here, and look at how much it's rising by from this point, which is our origin, okay? It rises up by 2,400, as we can see here, and runs by 2, okay? So what is our gradient? 2,400 over 2, which is 1,200. But remember what I said before, that 1,200 was actually right here, okay? It is a number before our letter n, and what does it tell us? It tells us that every single year, our interest grows by $1,200, okay? So if I was to analyze what happens after 1 year here, this goes up by 1,200. If I analyze what happens after another year, 1,200, and so forth. Okay, it's always going to be the same value that it goes up by every single year. Okay, that's what I mean by simple interest. All right, so we're just going to write down here that the gradient 1,200 shows the amount of interest earned per year. Okay, and you must write that. C, use the graph to estimate the simple interest earned after 4.5 years. Okay, so 4.5 years is right here on the x-axis. So we go up, we hit that simple interest line graph, and we go across, okay? And that value there, if we have a look at it carefully, is 2 little squares above 5,000. There are 5 squares extending from 5,000 to 6,000, which means that it goes up by 200 every single time. So if you go up by 2 squares, that's basically 5,400, right? So the answer for this question is $5,400 worth of interest. Part 2, when $8,000 in interest will be earned. Okay, so we have to look at our y-axis here of $8,000. Okay, when do we actually earn that? Well, we draw a horizontal line across, we hit the blue line, the simple interest graph, and we go down to the horizontal axis, and we look at how long it actually takes us. So, again, there are 5 squares here, okay, which means that each square, okay, or each space in total is 0.2. So this will be 6.2, 6.4, 6.6, 6.8, 7. So this number here is going to be 6.6. All right. So the answer for this question is it takes 6.6 years to go to 8,000. Okay, in simple interest. So that's 6.6 years. All right. Let's move on. Let's have a look at some examples from the actual exercise. Question 6. So this graph shows the simple interest earned on a principal of $20,000 for up to 5 years at 3 different interest rates per annum. So we can see that this same principal, 20,000, it rises up like at a more steeper gradient if the rate is higher. Okay, so the lower the rate, the less it will grow. The higher the rate, the higher it will grow. But each of these are still straight lines, okay? Just remember that. So according to this graph, how long will it take a principal of $20,000 to earn $2,400 if the interest rate is 8% per annum? Okay, so if it's 8% per annum that we're looking at, that means we're looking at the blue line, right? So with the blue line, okay, I'm going to look at 2,400, okay? So if I look at 2,400, which is basically here, right? Because there's 10 squares here, each square goes up by 100. So there we go. So if I now hit that blue line, okay, which is the graph with 8%, okay, I will be here, and that would approximately take me 1.5 years, as we can see, okay? So that's A as an answer. Question 7. So use the graph from question 6, which is drawn here, to estimate the interest earned at 6% per annum after 3.5 years. So we're finding simple interest here, and we're looking at the 6% graph. It's the middle one, and we're looking at 3.5 years. So let's go and have a look at that. So 3.5, it would be right here, down the center. If I just hit that line and go across, I am 2 squares above 4,000, so that is $4,200. Okay, that's how much interest I'll earn. All right, let's have a look at the next one. B, let's find the interest rate when $3,000 of interest is earned after 2.5 years. So we're looking at $3,000 interest, that's here, okay, after 2.5 years, which is here. So it's asking for us to find the interest rate. So if I just draw a line going across like that, okay, and I draw a line going up like this from 2.5, okay, where does it actually intersect? It intersects on this line, which is where the rate was 6% per annum. Okay, question C. the number of months it takes to earn $4,500 interest at 6% per annum. Okay. So we're looking at 6% per annum, which is this purple line. And we're looking at the number of months to earn 4,500, which is directly between 4,000 and 5,000. So we'll draw a horizontal line across like that. And we'll just hit that line, go down right there. Okay. And we can see that, well, this part is 3.5, and the line actually hits right between these two values. So if you add them up and then divide by 2, okay, that would equal to 3.75. Okay, so it takes around 3.75 years for it to earn that amount of interest. But after writing 3.5 years, I have to convert that to months. So I know 3 years is equal to 3 times 12 months, which is 36 months. Now, 0.75 of a year, okay, which is the decimal part of this number, that's the same thing as 3/4 of a year. Okay, so 3/4 of 12 would equal to 9 months. So what's that added together? That would become 45 months. Or alternatively, you can just times that by 12 on the calculator. You get that straight away. And that's 45 months. All right. Let's have a look at now part D, which is the time it takes to earn $7,400 in interest at 8% per annum. So 7,400. Let's have a look at where that is. Okay. 7,400 will be 4 squares. Okay. 4 squares above 7,000, and it's at 8% per annum. Okay. So it's right there. Hit the 8% per annum graph. Like that. Okay, and this extends all the way down. Okay, let me just extend that further. So you can see it. There we go. All right. So what can we see there? That looks like it is 6 squares to the right of 4, which is 4.6 years. Okay. All right. Part E. The interest earned after 21 months at 8% per annum. Okay, now this doesn't actually show the number of months, so we've got to actually convert this to years first, right? So to convert that to years, part D, 21 months. Okay, if I was to divide that by 12, gives you the number of years. Now, when you divide that by 12, you get 1.75 years. Okay, so let's have a look at 1.75 years and at 8% per annum. So 1.75 means it's 1 3/4. So it's the middle between 1.5 and 2. So we're looking at this part, and we're hitting the 8% graph, which is there, and we're just going across like that. Okay, so what did we actually get to? It is 2 squares just below 3,000, which means that's $2,800 worth of interest. Okay, I'm just going to write that right below here. So $2,800 worth of interest. Okay, let's have a go at F. The interest rate if $1,800 interest is earned after 27 months. So 27 months, again, if I divide that by 12, what would that get me? Okay, that would get me 2.25 years. So 2 1/4 of a year. All right. So 2.25 years, and at $1,800 interest. So if I look for $1,800, that's 2 squares right below 2,000. I'm just going to draw a horizontal line across. Then we were looking at 2.25 years. 2.25 is 2.25. So that's the middle between 2 and 2.5. So it's right middle between these two. Okay, that's 2.25. So we're going to draw a dot right there, go up, and see where it intersects right there. So what interest rate are we looking at? We're looking at an interest rate of 4%. Okay, that's your interest rate. Hope that helps you.